Okay, so let's get rolling, pun intended. So we are going to be looking at detecting collisions today with our collectibles that we added um, uh, last time. Let me just make sure. I don't think we added a trigger enter. Well, I'll see it when we pop up there, because we're looking at triggers and collisions. And the internet has been even extra slow today. Just gonna check my hotspot while we're all right. Let's see what we do with this.
Okay, what's next? Well, your players need to be able to collect the pickup game objects when the player game object collides with them. For this to happen, the game needs to detect the collisions between the player game object and the pickup game objects and use this information to trigger a new behavior. It's really important to test the collisions carefully. The pickup objects, the player's sphere, the ground plane, and the walls all have colliders. Without testing, the player might be able to collect and disable the wrong objects in the scene, for example, the ground plane. Let's get started. In the project window, go to the scripts folder and open the player controller script for editing. Before you begin writing the script, let's think about what the code needs to do. It needs to detect and test collisions on the player's sphere collider. To do this, you're going to use the function onTriggerEnter. Imagine that you're playing a platform game, and you jump up to collect a perfect arch of coins, but bounce off every first one and fall back to the ground. That's not very elegant. The onTrigger function will detect the contact between the player game object and the pickup game objects without actually creating a physical collision.
So this is an important thing with colliders. I know we really haven't talked about colliders too much yet, but we can allow the built-in physics engine to allow objects of certain masses or whatever rigid bodies to bump into each other and bounce off each other as physics would, decide based on the speed at which they were going, yada, yada, yada. Or what we can do is we can effectively become aware when a collision would have happened and then programmatically deal with it, where maybe we don't necessarily want to actually have a physical reaction where our player ball bounces off one of these things or gets, redirected or something at the very least. But we do want to kind of collect it and that kind of stuff. So we can use this onTriggerEnter to get a event to fire whenever the in this case we're inside the player controller, when that interacts with a something from the other another collider.
Let's start with the function declaration and parameters. Beneath the fixed update function, write void on trigger enter.
Now I'm guessing we can get to this build in for us. So we have our player controller here, and you could put it wherever you want. And I'm going to say on trigger enter, just start typing that. And that's going to fill out the thing here where we're going to have a collider. This is the thing that we bumped into. And I'm almost certain they're going to use tags here. So we'll see where they go. But effectively, this will get fired whenever the game object that this player controller is attached to, which is our player or rolly ball guy, whenever it collides with some other collider. And then we can decide if we care about that particular collider. So for instance, we probably don't care about the floor. We don't care about the walls, but we do care about those pickup objects. So we're probably going to use tags to say, hey, is the thing that we just bumped into, if other dot tag is equal to, actually, is it a dot equals, let's call this guy pickup. If that's true, then we want to pick up the item. So we could probably say destroy other. That'll probably let us accomplish what I'm thinking. They're probably going to write it something different, but for right now, I'm thinking it's just going to be, if we run into something that has a tag called pickup, go ahead and destroy it. Just as a starting point here, let me just jump into Unity real quick. I'm going to go to my pickup prefab. And I'm going to come up here to where it says tag. And I'm going to add a tag. Call this guy pickup. So I just gave it a I basically named all items of type pickup. So anything that's of prefab pickup is now tagged. Let's see, do I do it from the... So now they're tagged pickup. And that should have updated all of these. Yep. Okay. And if I run this real quick, my current belief is that, oh, the do I not have, I do have a box collider on my ball, but do I have a collider on my pickups? I do have a box collider. Oh, so I have a box collider on this. So notice already, so this just kind of goes into what I was saying before. Notice that when I try to, I'm bumping into these guys, all right? Because right now they're operating on the default physics. Now, if instead I set the box collider on my pickups, if I set this guy to be a trigger, then I run this again. Now it's going to go through those on trigger enter dealy flippies. Right, I'm not getting into the if statement there, but we can explore that here in a second. At least I don't think I'm getting into the if statement. Let's just make sure that we're getting into the function first. Let's see, what is it? I think it's just print in on enter print found pickup. Just doing a little debugging here. And that'll print it to the console. And I'll show you where that is in here. Go and click on the console down here. Okay, so notice here that it saw that I'm there. So every single time I've interacted with one of these guys, it says in on enter, and then it's noticing that I'm in found pickup. I'm just not destroying the guy correctly. So other, what is this dude? Maybe going to destroy that game object, not just destroy the collider. I bet you that's what it is. There we go. Ninja. All right, we'll just assume I'm perfect at this game and I'm just kind of sucking for whatever. All right, so that's roughly what I'm guessing she's going to have us do. Let's follow along with what she's doing, but that's kind of maybe how I would have done this. I just wanted to interject there and throw in that idea of the trigger versus a physics-based collision. Trigger allows us to programmatically decide what we want to have happen when two things collide, as opposed to just letting physics do its thing.
Open brackets, collider, other, closed brackets. Next, remember to add a set of curly braces to contain the function body. OnTriggerEnter will be called by Unity when the player game object first touches a trigger collider. It will be given a reference to the trigger collider that has been touched. This is the collider called Other. This reference gives you a way to identify the colliders that the sphere hits. You could destroy the game object that the trigger collider is attached to. However, in case you want to add additional functionality to the collectible objects later on, in this project, you'll only deactivate the game object rather than destroy it. So how can you deactivate the correct object, and in this case, the pickup game objects, using a script? Let's start to write the first line of code inside the function body for OnTriggerEnter. You can address the other collider's game object through other.gameObject. To disable it, you need to use the method setActive. This method accepts a Boolean value inside the parentheses, that is true or false. Use false to disable the game object. The full line should be other.gameObject.setActive, open brackets, false, closed brackets, semicolon. This code will disable game objects correctly, but you don't have a way to filter which game objects the sphere can disable. In the next video, you'll use the Unity tag system to do just that.
Okay, let's see what her answer is on the difference between destroying and disabling. Unless it's just a matter of being able to bring them back easily when you reset the game. Tell you what, the Starlink has been disappointing. They do have a hotspot as a backup, so one way or another, we're going to get it all to work.
Now, you've written code to deactivate game objects that the player game object collides with, but this should only apply to the pickup game objects. The ground or walls disappearing would not be good. To do this, you're going to use the built-in Unity tag system. Tags allow you to identify a game object by comparing the tag value to a string. The first thing we need to do is set up the tag value for the pickup object back in the Unity editor. In the project window, go to the prefabs folder and select the pickup prefab. You can also use the arrow next to one of the prefab instances in the hierarchy. This opens prefab edit mode. In the tag list at the top of the inspector, there's a few pre-made tags, but there's nothing called pickup. Select Add Tag. This brings up the Tags and Layers panel with a list that's currently empty. To create a new custom tag, select the Add button to add a new row to the tag list. In the new empty element, which will be tag 0, type pickup. This is case sensitive, so be careful. It needs to be exactly the same string that you use in the script. You can close the Tags and Layers panel when you're done. Now you need to apply that tag to the prefab asset. Select the tag dropdown again. You should see that your new tag is now available in the list. Select this tag from the list. The asset is now tagged pickup. Use the arrow to leave prefab edit mode. And with the power of prefab, all the instances are also now tagged pickup as well. Great! Save your changes in the Unity editor before you return to the script. In the next video, you'll use this tag to make sure the sphere can only disable game objects with the pickup tag.
Just real quick, I want to do well, whatever. So here's the conditional thing that we've already written, but let's just go through the motions in case she does something interesting. But again, while this is loading, these tags are our way of associating a sort of like a variable name to game objects, but since we're doing it with a prefab, we can do it to all game objects that are duplicates of that prefab so that we can easily identify things of that type in our scripts.
Now that you've created a pickup tag, you can use it to make sure the sphere only disables the correct game object. Let's do that using an if statement. This means that if a certain condition is met, the script will behave in a specified way. To create the if statement, you're going to use compare tag. Compare tag can compare the tag of any game object to a string value. At the top of the function body for onTriggerEnter, write if, open bracket, other dot gameObject dot compare tag, open brackets, and in quotation marks, write pickup, and then close that statement with 2 closed brackets.
So my feeling here is that so a game object has a function called compare tag that takes a string as a parameter, and then behind the scenes it compares that string to whatever string is associated with that tag. So I think what we've written effectively is equivalent. I've said, give me the tag property, tag attribute, tag field of this collider. See if it's equal to the pickup, as opposed to what they've written is they said, let's take the collider's game object and compare its tag to pickup. This accomplishes the same thing. It's possible that it might do a little extra checking under the hood. So best practices is probably to use this built-in function for compare tag, but ultimately we saw that it accomplished the same thing. Just something to clarify there.
This is the if statement. Be careful here. Comparison is case sensitive. Make sure to write the tag exactly as you did it in the Unity editor. Next, add a set of curly braces and cut and paste the line that reads other.gameObject.setActive, open brackets, false, close brackets,
Let me look at the set active dealy flippy thingy. So they're disabling it instead of destroying it. Before I play the video anymore, let's just see what the behavioral difference of that seemed to be. Okay, well, so one thing we will see, and I'll show it to you here in a second. Notice over here on the left, those other game objects are still there. They're just disabled. As opposed to if I'm going to go ahead and get rid of, well, it's going to take me a while to get that last one, but let me just show you here. If I go back to my destroy version of this, now you're going to see they actually will disappear over there. So we are actually removing them from the scene. All right, so they have now gone. I can't speak with absolute authority as to whether or not there's an advantage or disadvantage of those. On one hand, when you destroy a game object, you are telling the operating system to reclaim resources, although it did seem like when we ran it, it kind of staged them there to be reclaimed later for like automatic garbage collection. But you know, going and saying go ahead and reclaim resources now does take time, as opposed to kind of just turning the lights off on them and just saying, hey, we'll come back and deal with you later. So it's possible there's a performance advantage to disabling or set active, setting active to false, then destroying it. But visually, they gave us the same
Semicolon.
Same feeling.
Now this code will be called every time the sphere game object touches a trigger collider. It will receive a reference for the collider that the sphere has hit and then check its tag. If it is a collectible object, the script will call setActiveFalse, which will deactivate the game object. Let's save this script and then return to the editor and enter play mode to test the game. So the tag is set correctly, but the sphere is still bouncing off the pickup cubes, just like we were bouncing off the walls.
And remember, that's because they currently have their collider set to be a normal collider, not a trigger. So she's going to go in and change the collider on the prefab to be a trigger, which means that it'll follow the rules of calling that event on the script to let us programmatically deal with what happens when there's a collision, not just letting the physics engine figure it out.
In the next video, you'll explore why this is happening and fix it.
Okay, let's keep trucking. So I guess we've kind of done these things in reverse relative to her, but that's okay. That lets me get some of my commentary in.
So, you created tags and used them to differentiate the pickup game objects. But when you tested the game, the sphere didn't disable them on collision. This is because the pickup game objects are still using normal colliders and not triggers. Remember, colliders will stop physics objects from overlapping with them, which is perfect for a wall, for example, but triggers will just notify you if something is overlapping without stopping it. You can fix this issue by making the colliders into triggers or trigger colliders. When you turn a collider into a trigger, you can detect the contact with the trigger through on-trigger event messages. When a collider is a trigger, you can do some clever things. You could place a trigger in the middle of a doorway in, say, an adventure game. When the player enters the trigger, the minimap could update and a message could be displayed to tell them you have discovered a new room. Or, every time the player walks around a particular corner, spiders might drop from the ceiling because they have walked through a trigger. You have already used on-trigger enter in your code, rather than on-collision enter. Now you just need to make sure the collider is set to be a trigger. Let's get started. First, check that you're not in play mode. Changes made in this mode won't be saved. Next, go to the prefabs folder in the project window and select the pickup prefab. Now find its box collider component in the inspector and enable the Is Trigger checkbox. Now, through the power of prefabs, all the pickup game objects have trigger colliders. Let's save the scene and enter play mode to test it. Okay, as the player's sphere enters the trigger, the pickup game objects disappear. Excellent. Everything looks great, so you can exit play mode. You're almost done on this section of the project. There's one last tweak to make in the next video.
Okie dokie. Add a rigid body to the pickup prefab. I feel like we already have that. We do not.
There's one more tweak you can make to the collectible cubes, adding a rigid body component. Any game object with a collider and a rigid body is considered dynamic, which means Unity won't treat it as static or stationary. You don't want the pickup game object to be considered static, as it will take Unity longer each frame to calculate the physics, and it will do this each frame because the cubes are rotating. The solution is to add a rigid body component to the pickup objects. In the project window, go to the prefabs folder and select the pickup prefab. In the inspector, select Add Component and add a rigid body.
All right, so we're adding a rigid body. So I went to our prefab. And I'm going to add a component. I'm going to add a rigid body. And she says this is for performance reasons, that Unity treats a rigid body differently than a static object. So rigid bodies are dynamic. Means they're supposed to be in motion, so it lets the physics engine handle its movement rather than the game loop having to recalculate things that we know are not actually changing.
Save your changes, then test in play mode. And, the cubes all fall through the floor. The force of gravity is pulling them down, and as they are triggers, they don't collide with the floor.
Stop that for a second. Yeah, so now that we've made them rigid bodies, just like we did before, these guys now have gravity associated with them. So we'll watch that happen. Okay, so yes, we got those extra performances, but now if we hit the drop down on the rigid body, we can tell it to turn off use gravity. She might actually turn on the kinematic rather. But let me just show you. I think there might be a performance benefit to that, but I'm not 100% positive. See, if I have gravity on and I have is kinematic on, they don't fall through. If I turn kinematic off, oh, I guess I would have expected them to fall through this time, but if I have both of those on, they won't fall through. But if I just have use gravity on, now they will fall through. And if I just have his kinematic on, they won't fall through because they're also not gravity. So I wonder if his kinematic allows them to be dynamic without gravity being a thing. But to be honest, I don't know exactly what the is kinematic does. So let's keep listening.
If you find the rigid body component in the inspector, you'll see that you could just disable the Use Gravity checkbox, which could prevent the cubes from being pulled downwards. However, this is only a partial solution. If you do this, even though the cubes would not respond to gravity, they would still respond to physics forces. There is a better solution. Enable is kinematic. This sets the rigid body component as a kinematic rigid body. A kinematic rigid body will not react to physics forces, and it can be animated and moved by its transform.
There you go. So by setting it to is kinematic, we basically get all the benefits of the rigid body by while also disabling it, even checking to see if it should have impacts from external physics forces, which we don't want. We want to be in control of whether this guy moves. Like she was just saying, we can apply the rotation like we did last class, but we don't want to have to be forced into it being shoved around by other objects. So we get the benefits of a rigid body from a performance perspective, yet we've removed all of the external physics interactions from it. So it's almost as if it's not a rigid body, but it's still dynamic instead of static.
This is great for everything from objects with colliders, like elevators and moving platforms, to objects with triggers, like your collectible cubes that need to be animated or moved by their transform. Let's save the scene again and enter play mode to test. Now the cubes do what they did before, but more efficiently. Excellent. So, to recap, static colliders shouldn't move, like walls and floors. Dynamic colliders can move and have a rigid body attached. Standard rigid bodies are moved using physics forces. Kinematic rigid bodies are moved using their transform. In the next section of this project, you'll count the collected objects and make a simple UI to display the player's score and messages.
Okay.
There's one more tweak you can make to the collectible cubes, adding a rigid body component. Any game object with a collider.
Where is it running? Oh, here. Displaying score and text. All right, so we're going to have some way of behind the scenes programmatically storing information about the things that are picked up. It'll be interesting to see how she does this. What I might do is I actually might create what's called the singleton, an invisible game object that has a script associated with it. We might go down that path. Let's see what she does, but we might go down that path maybe next week when I'm back in person. But let's see where she goes.
In this section of the project, you'll explore counting the collected cubes, displaying text, and ending the game with a message.
So this is really kind of going to be a real-time example of that MVC, that model view controller. What we already have happening visually is we have the ability for a player to roll over one of the pickup objects and collect it. It disappears. We don't see it. All right. So we're visually seeing something. That's the view. Now, on the controller side, we're really not doing anything. We're asking some questions on the controller side, and that's what enables or disables whether we visually see it. But what we want to start doing now is we want to start keeping track of how many of these things we collected programmatically. So the controller is going to have some variable that's going to remember the 1, 2, 3, 4, however many you've picked up. And then we're going to then have some sort of scoreboard that we will update visually with that current score. All right, so this is that back and forth cadence between the view and the controller.
First things first, the collectibles.
And just to pause it one more time, to connect this to where we're going, remember, we're bringing over our dungeon crawler that we've written in Java at this point. We're going to be able to reuse those objects almost in their entirety. We'll just have to make a couple of little tweaks. But those will represent the current state of our game behind the scenes. Yet we're going to have to make our view add up to what we want it to actually look like. So we kind of already have a good portion of our controllers built, at least the data structure aspect of our controllers from Java. Now we need to make the view visualize or show us what those things actually currently say, and then make it look cool or whatever. So that's kind of where we're going. And this is how this prepares us for that.
To count these, you'll need a tool to store the value of the counted collectibles, and another to add the value as we collect and count them. Let's add this functionality to the player controller script. Select the player game object in the hierarchy and open the player control.
Oh, I didn't even consider that. Since we're doing this inside of player, let me just get ahead of it a little bit. So I'm going to go back here. We had two different directions we could have looked at this from. We could have maybe attached, we could have done it inside the rotator script, which is attached to each of our pickups, or we could have even had a pickup controller on each of those pickups. So the pickup, let's say you have 10 pickups, okay, 10 of those little spinny guys. And we did the logic on the pickup side rather on the player side. So every single time the pickup became aware that it interacted with a player, it would disable itself. But then it would have to mark somewhere that it had been collected. And I might do that in something called a singleton. Maybe next, I'm sure it'll pop into my head at some point next week anyways, but if you want, remind me on Monday and I'll talk more about this idea of a singleton. We're going to be running into it pretty quickly anyways, but so we could approach the same problem, the solution to the problem from either of the two sides. Right now, we're doing it from the perspective of the player. If I'm the player, every single time I bump into something that is a pickup, I can increment a local variable. I don't need to worry about anything externally. Yet, if I'm one of the 10 pickups and every single time a player bumps into me, I disable myself and then I let some sort of global variable know that, okay, you got me. Here's one more value that should be added to the thing. Now we need to make that value available to the player so we can keep checking it. But in this case, we're doing it from the player controller side, which probably makes more sense anyways. So we can create just a private, maybe do this, call this guy pickup count, start off at 0. Private int, pickup count. And then whenever we, here right now we're doing the set active thing. Whenever we deactivate a pickup, we'll say this dot pickup count plus plus. And then if we want, we can go ahead and say this dot pickup count. We'll write it to our console so we can see it. So all we did is inside of player, we kept track of a variable called pickup count, made it global, so it's accessible anywhere inside of the class player controller. We do only change it inside of onTriggerEnter. Remember, onTriggerEnter gets called each and every time that one of our colliders with a trigger that is a trigger is collided with. So we can't make this a local variable in here because it'll keep getting reset. That's why we made it global to this class, but private within the class. So every single time we collide with something of tag pickup, we'll disable it and increase the number of pickup counts we found, and then we'll print it out just to prove to ourselves that it was working. So now I'll go ahead and run this, but I'll click it over to our console. So now you'll see as I roll into this guy. Okay, got it. So now we're at 1. Now we're at 2, 3, ninja, 4, and 5. All right, so we're keeping score behind the scenes. I'm proving to myself by printing out to the console that my variables are updating the way I want them to, but we probably ultimately want our scoreboard to be out on the actual game screen. So let's see where she goes with it.
The script for editing. First, let's declare a private variable to hold the count. This should be an integer variable, written as int, because the count will be a whole number. The player won't be collecting partial objects. Underneath the rigid body variable declaration, write private int count, semicolon. Naming the variable count makes it easier to understand its role in context. The game needs to start with a count value of 0. Each time the player picks up a new cube, it then needs to increase by 1. As the count variable is private, you won't be able to set its initial value in the inspector. You'll need to do that in this script. There are several ways you can set the starting value of count, but for this game, let's do it in the start function. In start, write count equals.
So what she's doing here is, and actually this is probably reasonable programming practice. What we did is fine. But if you look at mine here, when I said private int pickup, and I set it equal to 0 right here, that's fine. You can do that. It's not hurting anything. generally, when we think about the start function, we think about the start function as being kind of like our constructor or initializer. So that would be where we initialize all of our initial variables. We might decide to go ahead and set up pickup count inside of that start function as part of the initialization process of this script, as opposed to hard coding it right here. At the end of the day, it's not going to make any difference, but if you want to be consistent and just say all of our setup values are done inside of start, let's stick to that. The only reason we gave speed a value out here is because it was public and we made this its default value, and that is going to be changeable inside of the Unity inspector as we saw before. So that's not going to change the behavior of our program at all, but just something to point out as to why she's doing it that way.
To set the initial count value to 0, followed by a semicolon. Next, you need to increase the count variable when the player collects a cube. These cubes are collected or disabled to make them disappear in the onTrigger if the other game object has the tag pickup. That means the onTrigger enter function is where you need to add the counting code. After setting the other game object's active state to false, add another line of code to add 1 to the variable count, then save it back to that same variable. This is a basic form of incrementing a value. To do this, write count equals count plus 1, then add a semicolon. There are other ways to add, count up, or increment the value when coding for Unity, but this one is the easiest to explain visually. Now save this script and return to the Unity editor. In the next video, you'll create and configure a UI text element so that you can display the incremental count value to the player.
Okay. So now we're going to add a scoreboard to the game, this UI text element.
Now you can store and increment.
And more than likely, the way she's going to do this is she's going to set the UI text element as a public variable so that we can drag it into the script. So this is the way I'm seeing her doing this. This is MVC going in the other direction. Instead of having a public variable in our script being made available to Unity's inspector, now we're going to make something that's in Unity available inside of our script. And if she doesn't do it that way, I'll do it that way. So one way or another.
Collectible cube count, but there's currently no way to display it. To do this, you're going to use two systems built into Unity, the user interface or UI system and TextMesh Pro. Let's get started by creating a new TextMesh Pro text element in the Unity editor. First, in the hierarchy, select the Add button and go to UI, Text, TextMesh Pro. A dialog window will open to install TextMesh Pro Essentials.
All right, so let's do this. Come over here, hit plus, UI, TextMesh Pro. I'll import the TextMesh Pro Essentials. This is the first time I'm doing it for this project. Okay, I don't think I'm going to need the examples and extras, so I'll just leave that undone. All right, and what this does is it creates a canvas for me. Let's see if it puts this on the back. Where's my camera? Game score on there for right now, and it's already right. So that's currently my score, but right now I need to see where that is relative to my camera. I feel like it's on the wrong side. Maybe. not behind me, is it? Might. So that is the score right there. The camera is facing me. I'm guessing when all is said and done, there's going to be a better way of accomplishing what I'm doing here. Maybe I should just let her tell me. Just keep cooking with her.
Select Import TMP Essentials.
He makes it a child of the
These resources will be added to a new folder at the root of your Unity project. Close the window when you're done. Now you'll see that some new things have appeared in the hierarchy. Let's review them. There's text, TMP, the UI text element. There's also a parent game object for that text element called Canvas. And another game object called Event System. These game objects are all required by the UI toolset. The single most important thing to know about these additional items is that all UI elements must be the child of a canvas to behave correctly. Rename the text element game object count text. Now, select the canvas and press the F key to see the entire game object in the scene view. Then, select the 2D toggle at the top of the scene view to change to 2D view. The default text color is white. The size and alignment are good, but let's add some placeholder text. In the text field, at the top of the component, add count text as your placeholder. Now, to avoid getting in the player's way, it makes sense to display the count in the upper left of the screen when a game is playing. It's currently in the center of the scene. This is because the text element is anchored to the center of its parent, which is the canvas. It is worth noting here that the transform component on a UI object is different from the other game objects in Unity. For UI objects, the standard transform has been replaced with a rect transform, which takes into account many specialized features necessary for a versatile UI system, including anchoring and positioning. One of the easiest ways to move the count text element into the upper left of the screen is to anchor it to the upper left corner of the canvas, rather than to its center. To do this, select the icon at the top of the rect transform component, displaying the current anchor preset. This will open the Anchors and Presets menu. Hold Shift and Alt or Option, and select the top left anchor point. Holding those keys will set the pivot.
So let's get caught up to where she is here. So I know I've already moved this thing all over the place. All right, so now it's in the upper. So if I click on that text, actually, is it click on the canvas and then click on 2D? There we go. So the canvas I need to do the anchor with. No, seems like it's. Oh, so I think all my dragging around the stuff has messed it up. There we go. So I've repositioned it at 0, 0, 0. Now it's in the upper left of the 2D thing. Still don't think I'd see it yet with the when the game runs. Oh, I do. So it's just in a different space. All right, well, so then just for the sake of time here, what I'm going to do, I'm going to come in here and I'm going to create a public UI, what's it? Public text mesh game score. And then down here, instead of printing, I'm going to say this dot game score dot set text. What is that? Just dot text maybe is equal to game score concatenated with this dot pickup count. All right, so by making that public, and then every single time the score changes, I'm just updating that this text on it to whatever the current pickup count is. The last thing I need to do here, though, is I need to come out of 2D mode, maybe. Let's go to player, because player is the one that has this script. Here's my script. And notice that it's expecting this game score text mesh. I'm going to drag my text mesh over to here. Isn't that where it goes? Oh, it's a text mesh pro. It's a disaster. What kind of animal is this text mesh? I must not have the right kind of. It's a text mesh pro. TM Pro. Oh, do I need to do using TM Pro up here, which then will give me a text mesh pro. Do I still get a dot text from that? Yeah, I do. That was just giving me the right kind of animal. So now under this, it's expecting my text mesh pro. Now I believe I should be able to drag this guy in here, but clearly not. I have to give it the whole canvas. No, well, let's let her keep cooking then.
And position for the count text based on the new anchor. And now the UI text is up in that corner. Great. It does look a little cramped though. Let's add some space between the text and the edge of the screen. The simplest way to do this is to change the rect transform components pos x value to 10 and pos y value to -10. Now that looks better. In the next video, you'll make the UI text element display the actual count value for the game.
Let me expedite a little bit here, so I can get the video finished and uploaded right before class.
Now that you've created a UI text element to display the count, let's connect this to the player controller script to get it working. In the project window, go to the scripts folder and open the player controller script in your script editor. Before you can code anything related to the text mesh pro element, you need to add information about it to the script. The details about the UI toolset are held in what's called a namespace. You imported another namespace earlier in this project to access the Unity input system. To import the namespace for TextMesh Pro into this script, create a new line underneath the input system namespace and write using PM Pro semicolon. With this imported, you can now write code relating to the element. Next, underneath the public variable called speed, create a new public TextMesh Pro variable using the type TextMesh Pro UGUI called countText. Make sure to add the semicolon at the end of the variable declaration.
All right, I think I see my error here. Text Mesh Pro. GUI. Which should then allow me to not gonna help me. I needed this. Okay, yeah, this was correct. I usually would have done it from this side. I would take this and I drag it over here and land it in that spot. That's me connecting one of my visual game objects to the actual code behind the scenes. Now, if you look at my script behind the scenes, what am I doing? I'm going ahead and I'm updating that score every single time. So let's go ahead and run this real quick, make sure this is where we're at. So there's my game score. Now it's game score 1, game score whatever, 2, so on and so forth. Okay, so for your homework for Monday, and I'll be back in class on Monday, bring your game to conclusion like this, so it's keeping track of everything, and we will start getting our dungeon crawler being built based on these primitives that we now understand. Okay, I will see everybody on Monday.